In this lesson, we would be going over another application of derivatives, and that is sketching the curves of the given function, for which we will be given information in the form of conditions. The learning goal of this lesson is to sketch the curve of the function using the information given, and after going through the lesson, the students will be able to interpret the interval of increase and decrease from the given conditions. The students will be able to interpret the max and the min points from the critical numbers given in the information, and the students will be able to sketch the curve of the function from the given conditions. Let's understand this with example. Now let's say we have to sketch the curve of the function f, and we are given the following information. That is, the first derivative of the function is greater than 0, means it's positive in the interval for x less than -5. The first derivative of the function is less than 0, means it's negative over the interval of -5 to 1, and the interval when x is greater than 1. Apart from that, we are also given that the first derivative is 0 at -5, means this is the critical number given, as well as it is 0 at 1. So there is another critical number at x equal to 1, and the point for the critical number, or the max, min, or point of inflection, is given to us as -5, 6 and 1, 2. Whenever we have to turn the given information into a graph, the first thing we always do is to put all of this information in the table. So this is how we make the table using the interval. So we are given x is less than -5. Therefore, we have the first interval that is from -∞ to -5. The next interval is from -5 to 1, that's this one. And then the next interval is 1 to +∞, that's this one. In between, we see a critical number of -5 and 1 that we place in between the intervals like this. Now we're going to use the information given in the question and fill this table up. We know the first derivative is positive in this interval from -∞ to -5. So positive means we're going to put a positive sign here. The first derivative is 0 at -5. From -5 to 1, it's negative. And it's a 0 again at 1, and then from 1 to +∞, it's negative again. We will use these derivative signs to interpret how the original function would look like. So the function would be like increasing in this interval, decreasing in this interval, and decreasing in this interval. Since the preceding interval is increasing and the following is decreasing for -5, so -5 will show us a max point, and for 1, the preceding and the following is the same, that is decreasing. So at 1, we would see a point of inflection. Using all of this information, we will then sketch the curve. So the first thing we always do is plot these intervals. So the first thing we always do is plot the critical numbers, -5 and 1. Let's say is here. We would see a max at -5, and we are given the exact point where we would see the max, and that is -5 and 6. So let's say 6 is here. In that case, we would see the point here. For 1 and 2, we would see the point here. Before -5, the function is increasing, so it's going like this. Then after that, it is decreasing, and it keeps decreasing, showing us the point of inflection at 1, 2. And this is how we would get the sketch of the function f using the given information. We just noticed that if we want to use the given information to make a graph from the given information or from the given conditions for a function f, the best way is to first make the table, that is the interval table. From the interval table, we draw out the conclusions for the original function, and then we use the original function conclusions to turn that into the curve of the original function.